Hi guys, that's awesome. So what I want to say to you all is that all your roles are really important to provide benefit into your product. So this three legs tool or that one, it's basically representing the three main strong foundations of your product. So a product to be good, you will need to take care of technical, emotional, and commercial positions. Um, the commercial position, it's really about thinking we are making products, we are people making products that other people will buy. And we want them to buy them because we have jobs that we have to maintain. So basically, yeah, if we want to keep enjoying designing products and making products, we need to get them sold. The emotional position, it's really about what is the user feeling with the product. It can be really aesthetics. It could be the story behind, so the marketing guys can figure it out. Um, yeah, few other things that you can come up with. And obviously the technical position, as we are engineers, we know that something that is going to be released into the market has to work. So you better make it work. So really, we have to take care of these three things and how to make it or how to make it happen, basically. It's really easy. So as Daniel mentioned, I'm from Spain. And I came here to New Zealand a year and a half ago. And I got to know the Kiwi way of doing things, and it's basically this. Some other people call it the lean process. I call it the Kiwi way. So you basically build stuff, test it, measure it, learn, and you will come up with new ideas and start the loop again. Um, and this is good for all those three positions that I mentioned before. So for all of you, it's important. For technical, from the technical point of view, it's really easy to understand. You just have an idea or a concept, go prototype it and test it. Easy to catch. Now, for the commercial point of view, you can realize it. That is happening all the times with startups. They have to figure out their business strategy, and they will use something called the business canvas model, which is basically a diagram. Well, you all know probably. Diagram really easy to see and what's going on, coming in, coming out from the business. And according to the theory, you have to update that business model every day. So that's just, again, doing that loop. And now when you talk about the users, what they feel, you're talking about the emotional part of the product and the business. That gets a little bit more abstract. And, but you should take care of it still. And this is the best way of doing it. And because really, at the beginning, you have to nail down what are your requirements and what you're going to do with your product. And I'm going to expand this a little bit more, because that's, as I said, a bit abstract. I can change from different type of products or services. Okay, so something that we should remember is that we don't sell products to people. We sell to people, well, we provide to people the ability of becoming a more awesome person by using our product and basically buying it. But that's what you have to remember. So the guys from Cheerios know that properly. And this is the best example of what I just mentioned. In this advertisement, you don't see, well, you see, Cheerios, be happy, be healthy. They're not showing you the protein content or the fat content of it. They're just stating, be happy, be healthy. And if you look at it, they've got a trademark on that we sentence. So that made me think, oh, some people put a lot of effort on defining this, and why is that? And it's basically, you go to a supermarket, you get a guy buying Cheerios, and you ask him, he will tell you, well, yeah, I'm buying because they are healthy, okay, and tasty, yep. But these guys, they got to nail down, what is that? So, yeah, they are healthy, maybe that will make me feel better after eating them. I can be healthier, so basically happy and living longer and enjoying with my family more time, happy, blah, blah, blah. And I came up with that. And then I look at behind those words, a little bit blurry. It's just a guy enjoying with um, his daughter, I guess. So it's like everything in this advertisement is not focusing about the product, but it's just about that emotion that you are creating. And, well, this is difficult, as I said, to figure it out. And it's a bit abstract, but you can work around this process and basically coming back to processes. This is our design process. And we are gonna, you cannot see it, should be highlighted the first diamond. So you're making a product, you think that something is gonna fit the market in some way, and then you're gonna go through a journey of discovery. So coming up with a lot of potential problems to solve, but you really wanna focus on one. Because for the design team and for the technical team and commercial team, they need a problem statement fully defined, and from there, you can start designing. I'm not saying that that's the first part is not designing, but it's a bit different. And there are several processes and tools to go through this journey because it's really a learning journey, difficult. And, well, you can look at the design thinking tools and some other bits that you can use, but mainly it's fully divided in observation. Just go to the market, see what's going on, and figure out what are those needs, and a bit of analysis too. So something that those guys from Cheerios did really well is analyzing. So not only looking at the market, but realizing what's inside that customer or user. And that's tricky because you are dealing with sometimes with needs that not even the customer knows, and those are called latent needs. And just a wee example of what's that, I just mentioning this is from McDonald's 10 years ago. They were experiencing a really decrease on sales on their milkshakes, and they wanted to increase them, and they wanted to figure out what was going on. They made a huge error, and they put so much effort and money into making a nice flavor thick shake, and chemistry guys behind that, a lot of money, resources on that. And it wasn't until when they asked to the people, why are you buying this and who people is buying, that they realized actually everyone that is buying this, or the most people buying this, are mainly commuters. And the reason that they found out was that they wanted to have something in their hand that could drink during the whole commuting time. And for them to make a better product for these people, they just have to make the milkshake thicker so that it will last longer for the whole trip. So just having that in mind, there's a little bit of a, we don't want to fail like McDonald's. McDonald's can afford that failing and investing a lot of time and resources in some other stuff because they are McDonald's, but we are not. So I thought it was a good story. And right, we are still in the emotional frame of parts, and this is, as I said, a bit abstract. A great tool for validating ideas is something called the minimum viable product, which is basically anything, the most simple thing that can make you learn something about your product. And this could be, again, commercial or just user experience framework. So this represents one of those types of MVP, which is called the Wizard of Oz. So you don't pay attention to the guy behind the curtain. It's basically you fake the back end of your product or service. This is really well known for services like Amazon. When they started, really the founder was taking his car, going to the bookshop, buying a book and delivering to the people. But it can be used right now for physical products. And something that people have been doing, right now we have the opportunity of using crowdfunding platforms, you can literally have your idea, get someone like, I don't know, Motovated to make a render or a 3D model of your product, and just put it on an image, nice image, tell a story about it on the crowdfunding platform and see how the market is accepting that. And some people got really good at that. But I have to say that some people got so much funding that even with that funding, they couldn't manage to deliver a good product in the technical framework. So as I said, like, this is a three legs tool. You can focus on one, but you really have to take care of all of them. So yeah, this kind of MVP, minimum viable product, is a good way to figure out that problem statement that you will put into your design team and keep going. So you are able to go into this development. That's another journey. I love it, actually. And yeah, you have your problem totally defined, and then you're going to find so many solutions. Some of them that are going to be good, some of them that are not going to be good. And you really have to find your path into that solution that merges into a nice product, delivering benefit within a framework of time frame and cost. So again, talking about minimum viable products, something that is really useful to do, it's represented in this image. So this is called Evolutionary Design. And as I mentioned, minimum viable product is the smallest thing or most simple thing that you can make, and you can learn from that into adding value to your product. So the first image really represents shape and dimensions of a guitar that you want to design. You don't need to drill holes, you don't need 6 strings, you just want to validate something. Then, once you know that, you can really think about putting nice features like the tensioning system for the strings, represented in the second image. And you can have many ideas. And if you want to find a nice way to do it fast, you don't really have to build and reinvent the wheel many times. The third image really represents that you go to the shop, music shop, buy a new guitar, and just change that bridge that is your new design or your new feature to your product, and just see what's going on. And then once in the ideal world, you will validate all those pieces and bytes, you will put them together, and it will work. Well, sometimes that doesn't happen because there are some interactions that your technical team or whoever didn't think about them. And Daniel is going to talk a little bit about that, because there's a principle that if you follow through your design process, will help you to really nail down that joint architecture with a lot of features that work by their own, and they will work when assembled. And that's really similar to the KISS principle, so just keep it simple. And please, Daniel, if you can tell us a little bit more about that.
Sure. Thanks, Carlos. That's really awesome. So I guess what Carlos is talking about, we kind of more formally call axiomatic design. It's just a couple of principles that say if you have multiple functions in a product, keep those functions separate. Don't try and get two things doing two things at once, or one thing. That would be even worse. And keep everything as simple as possible. Don't have massive tolerance stack-ups. Just keep it really simple. So an interesting product I've been working on at Motovated for the last year or so is a better mousetrap, literally. And this guy here is really fascinating. If you want to talk about this with me more after this, I'm quite happy to, because I actually now fully understand how this guy works, and why it does, and why it's actually very difficult to scale it up. So in terms of axiomatic design, in this new mousetrap, or rat trap, or stoat trap, what we actually did was we decoupled the three main functions of this trap, which actually you might not know, but actually there's three. One is actually making it attractive to a mouse, which is your bait. The second one is actually positioning the mouse, which is putting it right about there, its head. And the third one is killing the mouse, which is all the dynamics that have to do with actually capturing it. Now, when we approached our problem, we just actually purposely divided our product development into those three key elements and worked on each one individually. So we've got the attractiveness nailed down, we got the capture nailed down, and we've got the killing nailed down. So, and each one of those we could develop individually and separately. So they're all on completely different development tracks, and then when you bring them all together, they work really well. I think that's axiomatic design in a bit of a nutshell. Now, I guess we kind of talked about the benefit of a product and how you can make it work. There's a really important aspect that it does work. I remember when I was at F&P, we have heaps of A3s or some discussion documents that explain what specifications it should meet, what it should do in this situation and that situation, but never once did it ever say that the product should actually work. So, it should meet this requirement and that requirement, but at the end of the day, the product has to work. It doesn't do anyone any good if you turn it on and nothing happens. And that it does so over time, that it lasts. Now, I guess one of the main things is in continuous testing through that cycle, what we're doing is we're trying to capture potential failures before they get to the customer. And I guess in addressing that commercial side of things, here's an interesting little data set from Rico. It's quite old, but it's actually still relevant. That if you capture a design problem or even a product problem in the design phase, you can obviously address it right then and there. But the further on you go through your product life cycle, and especially if it gets to the customer, you are in big trouble financially. You actually want to do as much as you can here while achieving that time to market. It's a challenge, but that's kind of the kind of challenges we like. So you can just see that those costs really ramp up, and essentially the last line is your warranties really coming into play there. You don't want to get those recalls. Now, in terms of your product resilience, you want most people want this for their product. They really want it to be strong and robust and really actually support a lot more problems than it might expect in the field. I don't know if anyone's heard of planned obsolescence. It's something you hear about. I've actually never seen it in my whole life. I've worked for companies and they try so hard to make their products last. It just, and if they can last a bit longer, another year, that's amazing. And they could even put a bit more warranty on it, and that will look really good from the business point of view. So, how can you achieve this? Well, you've got to really just start testing as soon as possible. So if you've got something you can hold, you really are at that opportunity for testing straight away. You're doing your market testing, your commercial testing, and you're actually doing physical testing. If you make something out of flimsy FDM or something, that printed plastic from a MakerBot or whatever, and you drop it on the ground, actually do look at it. You don't be dismissive like, oh yeah, well that was pretty weak to begin with. Actually, just take notice of how it broke, because it's actually a failure mode that is actually important for the product on that product's journey. I guess I'm an engineer. I'm quite fascinated by the technical side of things. I'm just going to give you just a little bit of a highlight as to what physical testing actually can bring to a product. Now, I guess in the simplest sense, a product is going to have a strength. You say it's got to be this strong and it's going to be subject to this kind of load here. Maybe you've got a pen or something and you break the pen. You're going to expect it's going to break, I don't know, so much of a load. Probably don't break it, I don't know. But in fact, it's actually statistical. Nothing's perfect. Everything's got tolerances, your materials and everything has that. So what actually happens is your loads can be higher or lower than expected. The strength of your part can be higher or lower than expected. And sooner or later, it can break because they're going to overlap and you're going to exceed those values. Now, when you have your FDM part that you've just dropped on the ground and broken, have a look. See how you might be able to make that stronger. What you want to do is increase that gap between your strength and your potential loads. So you're creating a confidence in your margin. Increasing confidence in your product performance by increasing that margin. Now, if you actually subject your product to all sorts of stresses, you give it to your manager or something to play with, they'll probably surely break it, or to some users, just keep a track of all the different ways they break it and just keep implementing fixes until you kind of say, well, we can't actually afford to fix that anymore. That's never going to happen. You actually have to decide and agree that that's going to be the case. Now, that's actually, in a nutshell, what highly exaggerated life testing is, or halt testing. You actually want to purposely expose your product to very extreme stresses. You want to build this margin out so big that there's really, really little opportunity in the field for it actually to fail. In fact, you can actually make that margin so big that when you make your product, at the end of the line, you can actually stress the heck out of it so that you're minimising out-of-the-box failures. And you know that you've got so much margin that you're not actually reducing the life of the product. I think that's good value. So you can be starting all of this conceptually right from the very first chance you've got it in your hand. You can even look at simulation to get some really quick, broad brushstrokes of how the product might respond before you even build it, and just take it from there. Yeah.
Well, thanks for coming along, and I hope you enjoyed this. We really talked so briefly about a few concepts, really interesting concepts, and not easy to understand. They are basically collected on an ebook that we developed recently, and we actually implemented the same processes that we are talking about for products for writing this, so it's pretty cool to watch. And you can also come to visit our stands around stand 110 and 145, a couple of those. You can see the new rat traps, and thanks for coming again.
Thanks, guys. Have you got any questions? I'd love some questions. Is there a picture of our rat trap? No, you have to come to our stand and have a look at it. Yes.
So you said you separate functions and then you add them together. Does that make a bigger, heavier kind of, it gives you a guaranteed solution, but do you ever then look at it and think, actually we can combine functionality and shrink it down, make it more compact, cheaper, easier to make, simpler, fewer parts?
Definitely, yes. So in terms of the product development journey, just that side before it gets to the customer, in terms of functions, what you can literally do is have one part per function, but you're not necessarily limited to having one function per part. So I'm just saying intrinsically you want to separate out the functions. It might be quite easy to separate each function as its own part, but they don't necessarily have to be separated. So, you might have, the screen housing for this computer. It actually does, quite a few different things, but each function could be tested separately. before you combine them all together. I guess that's the thing. You don't necessarily have to separate the function and the part. In terms of like prototyping, a good solution is to actually kind of like have a basic frame and insert like printed parts that may actually perform its own function. So while in production you might be planning that that it to be a single part that has many functions, what you can do within the product development life cycle is actually just kind of mix and match the functions and test each function. And you can also test the whole thing at the same time. I hope that helps. Yep.
Any further questions? Everything pretty clear?
Great,
you.
thank you guys. And Carlos?